What the heck is fire? Did we just accept this thing? How is it different from the idea of heat? This cooktop is hot, but why is a campfire equally hot, but it's giving off light? Easy. Fire's plasma, heat is heat. No. Plasma is matter so bloody hot, the molecules are moving so fast their bonds are broken, they're ions, it's a wild party turned ugly. This happens in the sun, but fire is nowhere near hot enough to be true plasma. So what is it? Well, the answer you've been waiting for. It's not special per se from quote unquote heat. Heat also gives off light. It gives off infrared light. We can't see it, but we feel it as warmth radiating off a hot surface. Fire gives off visible light, because that's what it's made of specifically. For example, wood, when very hot, molecularly breaks down and converts to ash and soot. This is carried into the air by the wind, and these particles, when they're breaking down, have excited atoms in an atomic sense, and emit photons, as commonly happens when any chemical bond is changed. Since they're in the air though, it looks like a bit of a flame dancing around an atom rather than emitting from the atom itself. Steel glows when it's really hot, because the molecules are on the surface, but light emission is the same idea in fire. Most things light up when really, really hot, due to the atoms becoming excited in certain states. However, the crux is if the molecules are chemically changing and floating away. That's about the whole story. Just chemical reactions giving off light, and where it's emitting from, and whether those photons are infrared or visible by us. What about explosions? How can we get something and make it go boom? Short answer, pressure. There isn't an inherent explosivity per se of things. When something's really hot, it transfers a bit of that heat to the surrounding air, and air molecules speed up and they want to spread out. A chemical reaction happens in gunpowder, which creates so much heat in such a short time, it both produces a gas and heats the surrounding air. Now there's more gas at ground zero. There's the gas produced by the gunpowder and the heated atmospheric air, and this creates higher pressure in that zone. So this has a desire to spread out and equalize. So it does. It moves in all directions, can push solid objects, pushes other gases and liquids. Sound comes from that shockwave too, as a mechanical wave in the air. Things moving come from that shockwave. The light, it comes from the same source as the flames, just the specific chemical bonds being broken or formed, which reactions there are emit light particles. Same for nuclear bombs. The uranium inside the bomb doesn't explode in your kind of idea. It kind of does, but nowhere near the scale of a nuclear weapon. It becomes so incredibly hot that in an instant, the surrounding atmospheric air all of a sudden is ridiculously hot and really wants to expand. A bit like a kid on a bicycle going down the road, and all of a sudden we've strapped the rocket booster to his back and now he's barreling into the bloody stratosphere. This intense temperature and pressure makes pretty much anything, solid, liquid, gas, go out in all directions due to the intense heat produced by the element, which also by proxy carries that heat energy outward too, and it's a bit of a cascading effect until everything's cooled off enough to chill out. Light, once again, is produced by the reactions giving off visible photons, and this is constantly happening in the sun.